Welcome to a new video. In this video, we are going to talk about principal component analysis, which I'm going to call as PCA from now on. Before we jump into the code, let's quickly talk about what PCA is and why it's so essential in the realm of data science. PCA is a statistical method that simplifies the complexity in high-dimensional data while retraining trends and patterns. It's widely used for tasks like data compression, visualization, and noise reduction. Okay, let's just import our libraries and directly start. We are going to import NumPy. We are going to import Matplotlib. As PLT, we are going to import Principal Component Analysis, PCA, from decomposition, import PCA, and we are going to import make classification from datasets, and we are going to work with the data which we are going to create with make classification in this lecture. So let's generate a dataset like X, Y, and we will say make classification, and let's say number of samples is going to be 500, number of features is going to be 10, and number of informative is going to be 8, and number of redundant is 2. Okay, now here is our dataset creation code, and let's just quickly check the X, and let's just quickly check the Y. And we have a binary classification problem, zeros and ones. Great. So the shape of the original dataset is this, and now what we are going to do is we are going to say PCA, and we will use the principal component analysis class, and we are going to say number of components 5. So you are going to see the change when I do X PCA, and I'm going to use PCA fit transform X, and after that we can just take the X PCA.shape, and you will see that it's 5 right now. It was 10 and now it's 5, so we reduced its dimension. So we are applying PCA to our dataset, specifying the number of components we want to retrain. In this case, we are reducing it to 5 components. The transformed data is stored in XPCA. So we have something like explained variance ratio, and we are going to see the performance of this from that, and I'm going to say PCA that explained variance ratio, and we are going to get this. Here it is. So the higher explained variance ratio is better. So what we can do is, actually let's talk about it more. I'm just going to tell it like simpler. The more explained variance ratio you have, the more you explain the data. Like the more you represent the original data. Not the data variance, but you can think it like data. Okay, let's set this like explained variance ratio, and let's just visualize this. Like I'm just going to create this variable in here, and I'm going to say plt dot bar, and I will say range length of the explained variance ratio, and actually it's ratio. Also I miswrote it in here, so I'm just going to do that. Now I'm going to say after this 2 explained variance ratio. Great. So after that I will say title explained variance ratio, and I will give the X label like principal components, and I will give the Y label like ratio, and I'm just going to use plt.show at the end of this, and here it is. We are visualizing the explained variance ratio to understand how much information each principal component retains. This plot is crucial for deciding the optimal number of components. Now we are going to train 2 models, one with PCA applied, one without it, and we will talk about the model performance difference we have. So it's going to give an idea like this, that if we train the model with the original data, what's the performance we get, and if we train it with the PCA applied, which means that a smaller data, how much the model performs, like how good it is. And yeah, let's use logistic regression as our model, and we are going to make the imports now. We will import sklearn.model selection import train test split. We will import from sklearn.linear model import logistic regression, and we will say sklearn.matrix import accuracy score. Great. So let's train the normal model firstly, and then we are going to train the model PCA applied model. So I'm going to say xtrain, xtest, ytrain, and ytest, and I'm going to say train test split x, y, and test size 0.2, and after that we can call something like model normal, and we can just initialize the logistic regression in here, and we are going to say model normal dot fit xtrain and ytrain. Now what we are going to do is we are going to do with PCA, we will say xtrain PCA ytrain, actually xtest PCA, after that xtest PCA, and after that ytrain and ytest, and then we will say train test split, and we will just give x PCA and we will give y, and let's set the test size as 0.2 again. Actually we need this in here for it to work, and after that I'm just going to run the cell, and I'm going to do model PCA and let's say logistic regression. We are going to initialize this, and let's fit this again like model PCA dot fit xtrain PCA and ytrain. Great. So let's make predictions with both, like y predictions normal, and it's going to be model normal dot predict, and we will use xtest, and let's say y predictions PCA, and we will say model PCA dot predict, and we are going to say xtest PCA this time, and let's get the accuracy scores, and we can just say accuracy score and ytest and y predictions normal. For the model we didn't apply PCA, and we can say accuracy score ytest and y predictions PCA, and great. So we got a better performance with the principal component analysis applied model, and this isn't the case all the time. You can just think about the model performances, and if you have other metrics you can use them, and you can decide about if you're going to use principal component analysis on your model or not. And that was all from me for this video. Thanks for watching it. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the cards of this video or the link in the description.